All right, let's go ahead and get started. Welcome everyone to ACES Introduction to Julia. My name is Wes Brashear. I'm an assistant research scientist here at the HPRC. This is my first real-time teaching Julia, so excited about that. I typically teach classes in R and Linux, and then my background is in genomics and bioinformatics, so I teach courses related to that as well. But excited to add Julia to the list. These slides are available on the course website. We should have a link to that posted in chat soon. So just a brief overview. First, I guess, the way I like to teach is like it to be as interactive as possible. So if you have any questions, please post them in chat or unmute yourself and ask. I much prefer that we, kind of all keep the same pace as we move through the material, rather than anybody getting kind of lost and discouraged. So definitely feel free to interrupt. What we're going to be starting with today is just a brief overview of Julia, then getting on to ACES and getting everything set up there. Then we'll be working in a Jupyter notebook with Julia, in which we will cover a variety of different topics. So operators, variables, and data types, some different data structures, flow control, importing data, and then finally data visualization. All right, so just a brief overview of Julia. It is a high-level general purpose dynamic programming language, really designed for high-performance numerical analysis and computational science. It started at MIT in 2009, so relatively new language. And the authors sought to combine kind of the best features of a bunch of different languages: Ruby, MATLAB, C, Python, R, and ended up with the first release in 2012. So right now, the release that we are working on is 1.10.2. The documentation for Julia is actually really nice, and very handy, especially for a newer language. There's plenty of help out there with the documentation, and then of course places like Stack Overflow and things like that. So some of the major features of Julia is that it is very fast. On the right here, you can see that somebody called Julia Python on steroids. And it really is kind of structured very similar to Python, except under the hood, it's much faster. It's a general language, supports a variety of different programming patterns. It is dynamic. And unlike Python and R and things like that, you can have typed data, where you specify the type of the data, which helps with speed and memory usage and things like that. And then all of the Julia packages work really well together. So it's a really nice environment. Where to work with Julia. Juno IDE was kind of the main IDE developed for the Julia language, but it's no longer under development. So VS Code is probably on your personal machine one of the better IDEs for Julia. There are a lot of extensions for Julia being actively managed there. We can also use Jupyter notebooks. All right, Ichia, Jenny. All right, great. I guess we'll keep going. If you want to throw in chat, if you're familiar with another programming language or languages, go ahead and throw those in chat. And that way we can make maybe some comparisons along the way. So like I said, I'm actually a fairly new adopter of Julia. I also use Python a little bit, R more extensively, coming from the life sciences background. All right, so Alex has got R, Python, and Bash. All right, so this should be, if you're familiar with Python and R, is this, you should be able to pick this up very quickly. There's, obviously going to be a few different syntax things, but it's very similar to the style of those languages. All right, so the first thing we want you to do is, excuse me, go to hprc.tamu.edu. I just threw the link in chat. And we're going to go to the ACES portal. So I'm going to do that now. Go over to portal, then click on ACES portal. All right, and you probably have to log in through ACES to get to this point. Can I get a thumbs up whenever you've successfully logged into the ACES portal? All right, so once we're there, we're gonna go to clusters and go to ACES shell access. All right, so that should print out this long message opening the terminal for us to use. And the first thing we want to do is we're going to make a new directory to store all of our Julia packages and stuff. And we're going to put that in our Scratch space. This Julia uses a lot of files for the packages. So it'll quickly fill up your home space, which has a 10,000 file limit. We'll be actually adding more files than that today. So what we want to do, is that font size good for everybody? Can you see my terminal? All right, thank you, Ichia. All right, so we're going to make dir, and we're going to put it in all caps or $ all caps Scratch /.julia. All right, and we are in our home directory, so you should be in home u dot whatever your ACES login name is. And so we're going to create a symbolic link to that, or symlink to the directory we just created. So ln space -s all caps Scratch /.julia. All right, and then if we look at the contents with ls and then -a, we should see, right, in this, I don't know what color is that, teal, turquoise, a link to Julia, the directory we just created. What's the all right, now we can see where it's pointing to. Scratch /user, and yours will be whatever your username is .julia. All right, and again, if you need more time on something, please speak up or post something in chat, especially right at the beginning. Now, this is all very critical and getting everything set up to where the notebook will run properly. All right, so if you miss something here, you might not be able to participate in the rest of the course. So I'll definitely take time and we can troubleshoot anything that happens as we're working through this, okay? All right, the next thing we're gonna do is load a module for Julia. We'll do module space load space Julia /1.10.2 -Linux -x86_64. And all of these commands are in the slide deck that's on the course webpage. All right. All right, so enough Bash and Linux stuff. Let's get started with Julia, huh? So to start Julia, we just type in Julia and hit enter. All right, and that'll bring up uh, the REPL. And this is going to allow us to install some packages that we're going to use today. All right, so this is a kind of interactive mode for Julia, right? So we can do something simple like 2 + 2, tell us it's equal to 4. What we want to do is enter the package manager. And to do that, we just hit the close square bracket, and that prompt should show up. So just type in that close square bracket I just put in chat, and you should see version 1.10, and then it should say package. All right, and the first thing we want to do, we're going to add some about 7 packages. The first one is, and to add packages, we'll just do add space iJulia. All right, and that should start installing. So this shouldn't take very long. Mine's already finished. Can I get a thumbs up if once yours is successfully run? All right, and the next package is called Pretty Tables. So add space Pretty Tables. All right, the next one is plots. It's not going to take us long to install all these packages. I think total it'll be like maybe 5 minutes of installing packages. So don't worry, it's not going to be all like this. All right, so let's do this real quick. I'm going to get out of the package repository by just hitting backspace. And then I'm going to exit Julia by typing exit, open and close parentheses. And then can you type in show quota? And check and see if you're actually writing files to your home space, because you may have filled it up already. If that's the case, because if you didn't set the symlink properly. Yeah. So it looks like you didn't create the symlink. So you'll need to copy your Julia file that you have in your home space to your Scratch space, and then create the symlink.
Yeah.
Can you monitor the chat and help with that?
Sure.
Did you hear me, or were you paying attention to
Yeah,
the issue?
symlink stuff.
All right. All right. Then I'm going to go back into Julia and then get back into the package repo. And I'm going to add CSV now. The next package we want to add is XLSX. We'll add data frames. And then the last one is called stats plots. All right, and then again that's the last one. So I'll press backspace to get out of package repo, and then Control L to clear the screen. And I'm gonna go ahead and just leave this up for now. But I'm gonna go back to the portal. But also, if you once you get this notebook, then you can save it to your own, home directory or Scratch space or something, and it'll be a good reference point, or you can just walk through it kind of on your own. All right, so what we want to do now is go to Interactive Apps and go down to Tutorials on Demand. And then it should bring up a screen like this. You should have a drop-down menu of different tutorials that we have. Make sure you select Introduction to Julia. You can put 3 for the number of hours there. And once that's selected, click Launch. And this will take a couple minutes to boot up and get the session started. All right, and so this button should pop up that says connect to tutorials on demand, introduction to Julia. So go ahead and click on that. All right. And once you're there, you want to make sure you're running the proper kernel. So if you click up here, select the kernel you want to use, make sure it's Julia 1.10.2. Hit select. And your kernel status should say it's idle. It should be a kind of a hollow circle whenever we're ready to go. All right, so this is a notebook written for Julia for this course specifically. Like I said earlier, this is going to be should serve as a pretty good reference for you in the future if you plan on coming back to Julia. A lot of these sections are kind of self-explanatory, and right now, as it sits right now, it's a fairly kind of referential document. We'll go through and add cells and things like that. But if you're not familiar with Jupyter and the way these notebooks work, we have a bunch of different cells that allow us to do things like put in pictures and logos and things, or various text, and makes it look real nice to explain the code and everything that we're doing. We can add tables. So you can see this is written in Markdown. And so to get the nice formatting, we just hit run. So this would be another one, little HTML there for the table. But again, just run, and the formatting should be nice. For this class, if you do view table of contents, that'll pop up this nice table of contents on the left here, which may be handy for you. But given all of that, let's go ahead and get started. For the first, I guess, topic here would be kind of running Julia on the interactive REPL, which we have some experience with since you all successfully installed some packages. There are a few different key bindings that make it really that help you get between different versions. So for instance, if we go back to our login, so from shell, say I want to go into the terminal mode. I just type in a semicolon and shell will come up. Then Control C to exit that. Control L clears your screen. Square bracket we saw earlier with packages. Backspace to exit that. So if you're working interactively, then it's a pretty nice kind of user experience there. That's typically not how I work. I like to work in kind of notebooks or scripts or something like that, or an IDE. So that's why I chose to go with this Jupyter notebook. And the first package that we installed, Julia, is what allows us to use get this Julia kernel in the Jupyter notebook and use it. All right, so moving on, we'll be working kind of pretty much just in the the notebook from now on. And we have to do the obligatory Hello World program. And this is kind of an explanation of these cells that we have in Jupyter that allow us to do either markdown or run code. So to run a code, you can hit command and return on Macs or control and return on Windows, I believe. And so we've ran this, what is a code cell, and the output is shown below. All right. So now, so you get kind of familiar with how these code cells work. Take a minute and create your own version of Hello World on the lines below. And we used the println function for that, which is very similar stuff you see in Python or R. There is a print function. So you can try that one too and see if there's a difference in the output. So I'll try print function. All right, I mean, that looks the same. Let's try another one. All right, so the difference between print and print ln is that print ln also moves a cursor or adds a return character on that, so that now you're on two separate lines. So I pretty much just always use print ln. All right, was everybody able to do their first Hello World program? All right, yeah, I mean, it's obligatory. We have to do it. Awesome. All right, so moving forward, we'll talk a little bit about comments in code and their syntax in Julia. So if you noticed up here, right, so everything that came after this hashtag or pound symbol wasn't evaluated by the kernel. That's because it's a comment, right? And so this is pretty standard syntax for all languages. The only difference, or maybe I guess language specific thing, would be multi-line comments in Julia. And for those, you start off with hashtag or pound symbol and then an equal sign, and then write your comment, multiple lines of comment, and then close it with an equal sign and hashtag. Comments can follow code in case you need to describe a specific line of code very clearly. Let's go ahead and run this. We can also run by clicking the play button up here. And so you can see now, even though we've got, I don't know, 8 or 9 lines of code, including the comments, that we only get these 2 lines of output. All right, so I guess we'll move on to operators then. There are no big surprises here. Plus, minus, multiplies an asterisk, divides a forward slash, exponents, we use the hat, and to get a remainder, it's a % symbol. Is that identical to Python so far? I'm not a big Python person. Oh yeah, print is different in Python for sure. Yeah, the print ln took me a while to remember to type. Exponents are different in Python, says Dr. Winchell. What are exponents in Python? That's right. Okay, thank you, Michael. All right, so what's comparative operators? I guess let's move on to those. Equality is 2 equal signs. Inequality is, again, an exclamation point, equal sign, or we can do a backslash and then type in NE and then hit tab, and that'll bring up this symbol here. And same thing for lesser than or equal to, or greater than or equal to. So to get slightly different, I guess, slightly different operators when using that functionality. So let's go ahead. Let me show you how that works. So we could say for any 5, and that's true. And that would be kind of equivalent to 4 exclamation point equals sign 5. All right, that tab does come in handy. I guess if we'll look at it later on when we're discussing variables. But just, a slightly different way of doing things. A little bit more about arithmetic operators. The order of operations follows just the basic math rules. The updating version of the operators is formed by placing an equal sign immediately after the operator. So I think that works in Python, but not in R. So x plus equals 3 is equivalent to x equals x plus 3. I think the weird one is the dot before a operator, which will automatically perform an operation element by element on like an array or a set of numbers. And then finally, numeric literal coefficients. Julia allows variables to be immediately preceded by a numeric literal, so I'm implying multiplication. Exclamation point is negation in Julia, and 2 ampersands or 2 ors would be the and or the or operator. So short circuiting in this case means that it doesn't, to save time, it doesn't always evaluate both sides of the expression. If the outcome can be determined by only evaluating one. There are you can use the single operators, and those don't have short circuit operation. So I don't know how much time you'd end up saving here, but if you're doing maybe a lot of comparisons using and or, it could stack up. Oh, also, we'll talk a little bit about this later, but Boolean is an integer type in Julia. It's there. Okay. Like I said, these are just the bitwise negation and or, and that is it for operators. All right, I think we can go ahead and take a 10-minute break. We've been going for about 50 minutes now, so I think it's a good idea. We'll come back at 3:02, and we'll move on to variables and data types. All right, and if you have any questions, you can post them in chat, and I'll try to answer them to the best of my ability. All right, thank you, everyone. We'll see you at 3:02. All right, so let's move on to variables and data types. In Julia, we assign variables with the equal operator, and follow a few standards that are pretty normal. The variable names must begin with a letter or an underscore. Names can contain any combination of letters, numbers, underscores, and exclamation symbols. And you can use some Unicode characters as well, which we'll do in a minute. There is no maximum length for the variable names, and variable names are case sensitive. To examine the contents of a variable, you can simply just type in the variable or use a print or println function. All right, Here in this code chunk, uh, we are first assigning x the value of 3. Then we're doing this incremental operation, x plus equals 1. This is something we don't have in R, and I really like this. I know it's a little thing, but uh, I don't know. It bugs me that it's not in R. And then what we're going to do is print out the new value of x following this short statement. And then you can actually use emojis, Unicode emojis in Julia. Why they included that functionality, I have no idea, but it's fun. So to get those, you just do a backslash colon, and then the name of the emoji, and then close colon and tab, and it'll pop up. So we're assigning the value of 12 to pizza slices, the value of tired to a runner, and then we're going to print 12 times pizza slices. All right, so run that. So x is equal to 4 now, and we have 144 pizza slices. All right, so down here is space for an exercise to add cells, or if you want to take notes in this, I highly recommend that you do that. You can just hit the plus button up here, and if you want to say do notes, put down markdown, and then you can, enter your notes here. So as we go through this, you can modify this however you want, and then at the end we can save it, and you can have this nice reference document for working with Julia. All right, so let's go ahead and look at this ability to use Unicode characters a little more. If you type in backspace colon, and then start typing, I don't know, happy underscore face. That's not one. Just type in HA and hit tab, and it'll bring up all of the different ones that are matching that so far. So we can say hamburger, and then hit tab again, is equal to 4, backspace colon. I don't know if there's French fries. I've not seen this before. So appears to be some sort of weird issue with Julia in doing this. We can just add in another code cell. There we go. All right. Any questions on using those? I don't know if you would ever use a burger and fries in your scientific computing, but if you want to, it is an option. All right. So let's move on to data types. So here's a graphical representation of the different number types. Oh, first, the one of the key differences between Python and Julia and R and Julia is that you can define the data type explicitly. So that'll help. If you need to save memory or something like that, you can define a number as like a float 32 instead of a float 64 or something like that. So that'll reduce your accuracy, and but it will decrease the amount of memory that you're using. or they can be just determined dynamically at runtime. So very similar to R or Python. So it can go either way. You don't have to explicitly define them, but that ability is there. And so we have these different number types. Float numbers, 16, 32, 64, and then what's a big float for handling large numbers, abstract irrational numbers. In the integer type, booleans are considered integers. And then we have signed and unsigned integer types, and all of those different sizes that you can explicitly declare. And so here's just a table with different information. So the number or the size, memory footprint there, and the smallest and largest value for each of these different integer types. And then the same thing for floating points. We have our types, the precision, and then the number of bits that's going to take up. So if this is something that you really want to streamline, there's a lot more documentation on it. If that's something that you're interested in doing, I definitely recommend following this link here. For very, very large integers and floats, we've got the big type. And so here, what we're going to do is get the type max of x and do x plus 1, and then print that out. And then look at the type min, and then finally we're going to be looking at the big type. All right, so the largest and smallest values for that type are shown, and you can see it has it rolls over whenever we're not specifying large, the big type. So once we get to the largest type, or the largest of that type, and then add one more to it, it'll roll over to the smallest. And then this is just a massive number. So if you do need to store very, very large numbers, that type is available. Are there any questions on that? So there are some useful built-in numeric functions, things like round, which will round the number to the nearest integer, floor, which will round whatever value is towards negative infinity. So always rounding down, ceil or ceiling for always rounding up, and then ABS or absolute for getting the absolute value of a number or a variable. All right, so that's all for numbers. In Julia, we also have characters and strings, and so it's slightly different than Python, where we've got or R, where we've got this character data, which can represent only a single character, and that's going to be denoted with just the single quotes, whereas string data types can be one or more characters, and those are denoted with the double quotes. In Julia, strings are immutable. Also in Julia, indexing is one-based. So if you're used to Python, I'm sorry. If you're used to R, it's the same, right? The indexing there. All right. We are going to go ahead and run this. We're creating a new variable called str_variable, and we're just assigning it the value of HPRC. And this is just to look at the different ways of subsetting or indexing that string variable. So 1 corresponds to the H. End would be the very last one. And to get 2 through 3 inclusive, we just do 2:3. Oh. she says in Python, the index of an array starts from 0. Yeah, yeah, that's so in R, the index starts with a 1. So there's always, well, it can cause confusion. All right. So that's strings. Interpolation is also allowed in Julia, similar to Perl, I believe. Does anybody use Perl, or has anybody used Perl in the past? I myself, you've used it, Michael? Yeah, I've never used it. But this is a pretty cool feature, I think, to where you can essentially interpolate the inside of these parentheses using this $sign operator. So if we do this, it says 1 + 2 is equal to 3. Daniel still has to use Perl, and he's sad about it. Okay. It's, I don't know. I look at some of the scripts from my colleagues, and I have no idea what's happening. All right. And then if we want to use a $sign literal in a string, then we have to escape it with a backslash. Some built-in functions for working with strings. Length is one. So here we're defining this new string. We're going to print off the length of the new string. We can identify whether or not a smaller string resides within the bigger string using occurs in, and that will produce a Boolean value, true or false, whether or not that's there. Finding the index of the first appearance of a character in string. We just do find first, or for the last one, find last. And then to repeat a string, we can just use the repeat function. So this will print off new string from index 20 to 24 inclusive, a total of 5 times. All right, so this total string length is 38. HPRC is found within the new string variable. The first appearance of capital H is at 21. Last D in this string returned nothing, because there is no D in that string. And then finally, we just printed off HPRC 5 times. All right, so all pretty basic stuff, right? And I hope you can just kind of refer to this as a quick guide whenever you're working with Julia in the future. So let's, we're through with data types. Let's move on to data structures. And I would say that this is probably, it's very similar to Python and what's available. We have tuples, which are immutable ordered sequences of elements. And so these are good for like small kind of fixed length collections of elements. So those can be defined with just these parentheses. And then to index, it's the same thing, right? So it's one-based indexing. So here we're printing off tuple 1, which was 1. And then here we've got this kind of tuple of tuples. And so here we're subsetting the first one and pulling out the second element, and then the first element from the second tuple in here, and then finally the second element of the second tuple. Arrays are kind of a large grab bag of like lists and vectors and tables, as Julia defines them as arrays. And these are mutable, right? So we can change them. And there's a lot of different built-in functions to manipulate them or even to generate them. All right, so here's some different functions just for producing an array. We've got the zeros function, and we tell it the type that we want, and then the number of rows and the number of columns. All right, and then we just produces an array of zeros. We can create an array with a pre-existing tuple. And so that without specifying type, we don't have to necessarily do that. It's going to default to float 64. And Julia will, all the numbers can interoperate together, all the number types. Julia can just, what it typically does is it just elevates the type until it gets to something that's inclusive of all the types. So there's the interoperability between the different types as well. And then there's a ones function, which is similar to zeros. So just producing these different arrays. Again, that last one, without specifying the type, we get that float 64. There's also like rand, the rand function for generating random numbers that's between 0 and 1. I believe it's a normal distribution. And or the fill option. So we specify what we want to fill the array with, and again, the number of rows and the number of columns. So we can see now that we've got this 2x4 matrix with all these different floats between 0 and 1, a very small matrix with B and B in it, and then our C matrix is just filled with the word C. All right, and then we can also just, of course, define the elements while we're initializing the array, separating the rows by semicolons. All right, and so the format of how that's printed off, whenever we do print ln, it shows it in square brackets with the rows separated by semicolons. If we do something like display, then it actually shows kind of the structure without those semicolons. Same thing, I think, if you just type in the actual name of the variable itself, do the same thing. But if you want to be explicit about what you're doing, then display. There are some built-in tools for kind of inspecting arrays, looking at like the number of dimensions with indims, the size with size. So it's getting the dimension sizes, and getting the element type of an array. So here we're defining our array again. Hit run. So it is a 2-dimension array, right? An X and Y axis, or rows and columns rather. And each one is it's a 3x3 array, and it is an int 64 array. And just to point out, we don't have, if you're doing like indims right here, the reason we're doing the print ln function is because in Julia notebooks, the only output that you'll see is from the last command that produces output, unless you call for it explicitly with a print function. So that's why those are included in those code cells. To combine arrays for horizontal concatenation, we just do 2 brackets, and then here we're combining 2 different copies of D into a new horizontal concatenation. And for vertical concatenation, we just use a semicolon. So if we run those, you can see that here's our array glued side by side, and so it creates a 3x6 array. Whereas with that semicolon, it's going to create that 6x3 array. All right, and so then lastly, some mathematical operations with arrays. We can, here we've got a single dimension array and a two-dimension array. And I mentioned this earlier, some operations require a dot before them in order to run or to be calculated element by element. And so that's why we have that syntax there. And then it also differentiates between what is, I guess, algebraic matrix multiplication or element by element matrix multiplication. All right. And just to point out, I mean, matrix multiplication in Julia is really fast. So if that's something that you need to do in your research, it's very simple to implement and even parallelize in Julia. So it's really, really handy for that. I don't know your field of study but if you do matrix multiplication, Julia is a great language for it. All right, so sets, as in Python, are unordered collections of unique elements. So essentially, I mean, we can use them. The main reason I use sets would be to get rid of duplicate values in an array. And so here we define it as a set and then provide it with this this array of different string elements. You can see we've got here, these are different taco types, asada, barbacoa, birria, asada again, pastor, and fajita. So if we run this, we can see now we've got this unique list of elements. It removed the duplication of asada, and we can see the type of these elements is string. To add additional elements to a set, we use the push function. And so here we're adding carnitas to this set. And again, this is unordered. So I'm not sure how it determines, I mean, it's not in order, but where it gets displayed here. To remove elements from a list, we can use the pop function. And I think this is the same thing that's in Python. So here we're removing fajita. And then we can use the in function to check a set for specific elements. So here we're checking for barbacoa. And it's in there, true. All right, and if we want to combine or compare sets, here we're generating another set of different taco types. And we can grab the union, right? So the ones that are shared between sets, or actually combine all of the elements into a single set. The intersection, grab the ones that are in both sets. And then we can see the differences with this set diff function. Now the order matters on these as far as what's returned. So here, birria, barbacoa, and carnitas are not in more tacos, and vampiros and chorizo are both in, are not in the first taco set. All right, so that order matters. Here's the intersect of the two, and finally, and here's the union. So all of the different types and gathered into a single set. We also have dictionaries in Julia, which I really like. Those are just groups of mapped key value pairs. So to construct a dictionary, we just use the dict function, and then give it our key, and then it's an equal sign and greater than symbol, and then specify the value for that. Excuse me. All right, so here we've got this new dictionary, animal groups, and just the names of what these different groups of animals are called when they're found together. So it's a business of ferrets, or a flamboyance of flamingos, a colony of ants. All right, and so this is the what that looks like. Um, to pull out a value, this is, I think, identical to Python again. Just print, or we just index with the name of the key. So that should print out flamboyance. And then here, this is the get function, which we're now looking inside of animal groups for coyotes. And the difference here is if it's not there, then we can tell it what we want it to print out if it's not found. We can use the has key function to see if there is a specific key inside of a dictionary, and to add a key value pair to a dictionary. Again, we'll do square brackets, and then the name of the key is equal to the value. So a group of goldfish is called a troubling. All right, so if we run this, all right, so now we've got, at the very end, we printed off our keys and printed off our values. And so we can see we've added in goldfish, and sorry, buffalo is not in there. It returned our NA because coyotes is not in there. And it returned the value for flamingos. All right, so that's it for the built-in data structures. On to flow control. So the constructs are similar to every other language. Syntax varies slightly. We have our if else statements. We do have to use end on those. So here we're assigning a the value of 8. If a is greater than 10, we're running this line of code. If it's less than 10, we're running this line of code. And if it's neither, we're running this line of code. So a is less than 10. For loops, again, same thing. For I in this range of numbers 1 to 5, we're just going to print the value of I, and then we specify end. Yeah, there's no like trailing colon on any of these two constructs. So it's a little different than maybe some other ones. There's no or trailing semicolon either. But that's the basic construct of for loops. And of course, you can do like nested for loops and if else statements inside for loops and things like that. Some other uses of for loops include array comprehension. So just this nice tidy way of generating an array of values from 1 to 10. For array enumeration, and then as generator expressions. All right, so now we've got this enumerated list or value of this array, the simple array of 1 to 10, and then summing up this x for x in 1 through 10. While loops, same basic structure. While a is less than or equal to 100, b equals a plus b, a equals a plus 1, and then we'll just go through that until this condition is no longer met, and then we end. All right, so I know I blew through that, but most of you, if you're sitting in Joomla, you probably have plenty of experience with flow control. If I went too fast and you want me to explain something like how a for loop works and you're just not familiar with it, I'm more than happy to. But I was kind of tailoring that to the level of experience I think that most of you all have with coding. Please let me know in the chat if you want me to explain anything in more detail, or give me a thumbs up if you're happy with those constructs, or if you have a comment, something you know, if you don't like the fact that there's no colon at the end of the for line. Ichi is good, Alex is good. They don't care about not having colons or anything like that. All right, and they're ready to move on. All right. All right, so you all already have experience with loading packages. You can also you can do that from the command line without entering the package repository by using the package. The package, yes. So here we import to use a package, we use either import or the using function. So here we're importing package, and then we're going to run package.add example. And so this is just going to add a new a new package to our library called example. So if we run this, that's going to take a few seconds. And so while that's running, the difference between the using and import functions is that when you import, you have to specify the name of the package before the function that you call, whereas with the using function, you do not have to specify that. So you can just call the function directly. All right. So now I can use the example package and the hello function from inside of that. All right, and it just apparently says, hello, Julia. It's a very simple function. And like I said, we can do import or using to import packages. And again, the key difference is you have to specify the package name and the function when using import versus just calling the function directly when using. All right. All right. So we kind of jumped through packages a little bit. And then we're going to go back to data structures because data frames comes from the data frames package that we loaded earlier. So it's not necessarily a built-in data structure type, but I think it is one that if you're used to doing like pandas in Python, has anybody used pandas? Probably namespace considerations. Oh, sorry, I've got derailed. Yes to pandas. If you're used to R, we have data frames and tibbles. So I just thought like that's what we use a lot of in R. And pandas I know is huge in like data science for Python. So I just wanted to introduce this this data structure type and a little bit about working with it in Julia. So again, we can with this data frame, we essentially are constructing it's like an Excel table essentially of columns and values corresponding to those different columns. So here we're saying using data frames, df is equal to we're saying the data frame function, and then we're just specifying essentially these three different columns that we want: birds, trees, and numbers, and then providing an array for each. All right, so this is, I mean, this syntax is very similar. And so now we see we've got each of these different columns that we specified, the element type that's in each. And so we can have, as with, most like Excel worksheets or something, we're going to have different data types in each column. So we're allowed to do that here. We can subset or splice data frames using the column and row names and numbers. So we've got that same data frame. And then to call just the birds column, we can do df, the name of our data frame, dot, and then the column name. And then you can specify that as a string or just explicitly like this without the quotes, and that'll pull the entire column. Here we're going to subset the data frame using index numbers of rows, and here rows and columns. So all very similar stuff to pandas and Python and R. So here we're pulling the entire birds column, the entire trees column, and then a data frame with just a single row here. So pulling row 2, and then finally pulling element 1 from row 2, which was hummingbird. To get the names of the data frame, we just use the names function. To get all, like, this is shorthand that I thought was could be useful to somebody. To get all the columns containing the letter E, we just do names and then df, and then we're retrieving everything that has an E in it. So that includes trees and numbers. If we want to get all columns of a specific type, this is probably more useful, right? So float 64, so that'll just pull out the numbers. And then finally, we can subset the data frame with the names function. So here we're using square brackets, and we're saying all of the rows, and then for the columns, we want everything in the data frame that is a string. So that pulled out our birds and our trees. All right, any questions on data frames? I know I'm going through a lot here, but the goal was to give you a real brief overview and then provide you with this documentation that you'll have to reference back to later on, since we only have 2.5 hours to cover an entire language. All right, thanks, Alex, TG, Michael. All right, so there are a number of packages that allow us to import data in a variety of different formats. We installed the CSV package, which obviously lets us read in CSVs, the XLSX package, which allows us to read in Excel files, which is really nice. You can read in things like R data files or stata data files, JSONs. There's all these different packages to read in data in different ways. Getting started with importing data, the first thing that you really want to do is be able to kind of tell where you are, and maybe the contents of the directory. In Julia, we can use the pwd function, which I really like, to get your current working directory. So it's this long thing here. So that's one that you shouldn't forget, right? That's going to be easy to remember. os.get, okay, yeah. So you have to import os just to get the current working directory. Yeah, okay, Alex. I beat you to it. I said it out loud. Yeah, but pwd, right? That's the same as command line, so that's nice. It's get WD in R, it's built in. And then get the contents of a directory, we do read dir. So I looked for ls, it wasn't there. So we can see we got all these different things in here. All right, so to read in a CSV file, it's very easy to use both of these packages. You just say, using or import CSV and data frames. Here we're reading it as a data frame, and then CSV dot, and then capital F file, and then we're going to be reading in carnivores.csv. And so that's just going to automatically generate a nice data frame ready to go for us. Right, so very handy instead of having to manually type in your data frame. So for XLSX, there's a few different functions. You can do the read XLSX function, which can be reading in this data spreadsheet. But that's going to read in all of the different worksheets. So you can see we've got 5 different worksheets in here to inside of that spreadsheet. To read in a specific sheet, we can use the .read table function from XLSX. And here we're reading, again, that data.xlsx file, and then the Raman worksheet. And that'll read in this fairly large data frame from that spreadsheet, and it's already formatted quite nicely. So very easy to read in data and create a data frame to work with. That's all I have for importing data. It's very easy. It makes Julia really nice to work with. Are there any questions? All right. Well, let's move on to data visualization. I didn't expect to make it this far this fast. So we can explore this a little bit. We'll be using the, how difficult is it to manually read in a file if it isn't nicely formatted? So if you're reading in like an Excel file that's got some differences, like if it's like, like a bunch of numbers and there may be like NA values or something, that's not terribly difficult to work with. So if it's in that format, it's not too bad. I don't have any experience like reading in JSONs or anything like that. So I think it would be kind of a case-by-case basis on how difficult it is. All right. All right, so here we're just going to read in a data frame, SEC, from that spreadsheet, and it's just baseball stats from some SEC teams and players. And we'll be using the plots function just to plot some of this stuff out, which is there's a lot of different plotting packages out there. So this is a fairly popular one. So we'll read in this new data frame. All right, and we got the names of the columns. So there's player, team, position, number of at-bats, and then various hitting statistics. And so here I'm going to create a scatter plot based on this data that I just read in. So let's go ahead and let's take a look at the data. All right, so again, just the players, the team, and then their position. So a nice data frame of just different stats. And I use baseball stats because they're good for graphing. So here I'm going to use the plot function from plots. And I tell it that what I want to plot as my x-axis, what I want to do on my y-axis, the type of plot I want here. I can give it a label, and then an x-axis label and a y-axis label. So it's all, I mean, uh, hmm, if if you're used to like ggplot2 in R, I find this to be, I don't have as much experience with this yet, but it doesn't seem to be as difficult to use as like ggplot2. Um, so, and a lot of the, even the, well, a lot of the like flags and stuff are very similar to what's there, but it seems easier to use. So if we run this, all right, so a fairly nice looking figure already. You can see there's a good correlation between the number of runs batted in and the number of home runs. So really easy to plot quickly, and there's going to be all sorts of different flags that you can use to specify, um, things like color or what have you. Let's see, what is color? We can modify this. We'll just say color is equal to maroon. All right, so that we're changing that. I know you can like change the position of this, um, and so on. So pretty easy to do, like a scatter plot. You could do this. It won't look good, but line plot. um, so pretty straightforward. For something like, let's try we have time, but let's try like a histogram. We can, the function for that, since we're using plots, is just histogram. And then we'll do the RBIs again, and we can label it RBIs. All right, so generating real quick a nice histogram. Again, to just change the color, we could do color equal to hot pink, maybe. All right, that's a very quick and very decent looking graphics. If we want to do something like box plots, you'll have to use a different package called stats plots. And then we'll do a box plot, and we can do it by team, would make sense. And then we'll just do the RBIs again. And this should RBIs per team. All right, that gonna take a little bit longer because got to import that package. All right, but we've got these nice box plots. Yikes. All right, so quite a bit of overlap here. You can rotate the x-axis labels. There we go. So now they're more readable. I mean, it's just very quick to generate graphs, which I really like. Let's do one more, I guess. Let's do the ramen data set. View table data.xlsx, and then we're reading in the sheet named ramen. Doesn't like that. All right, there we go. And we'll do a box plot. Ramen, the brand. Let's look at ramen first. Yeah, so we have brand, variety, the style, whether it's a cup or a pack, and the rating. You can see these are any type. So that may cause a problem since they're not numeric data yet. Do box plot, ramen brand by the rating. All right. All right, so I think we're gonna have to filter out the data. So if we do, we'll make ramen equal to, we'll use the filter function for this, which I didn't show you, but I just wanted to show it to you now. We'll filter by stars. We'll make sure all that data is numeric, and I think it's labeled like unrated or something if it's not, if it doesn't have a rating. So pulling out everything that's unrated from the ramen data set. So again, we're pulling this column of things that we want, filtering out anything, or just leaving stuff that's not equal to unrated. We'll try this. All right, that's something. There's too many, I think there's just too many in here. So we can filter again. This time we'll filter by the country. We'll say anything that's equal to, I think the UK is not in here very much. So we'll get a really small data set. All right, there we go. And so again, we'll need to make some modifications. We'll do X rotation equals 30. All right, and so now we can see we've got this nice box plot of the different quality scores by brand name from ramens in the UK. So pretty quick to filter everything out and work with data. I think that's all I have to show you. Are there any questions about? I'm not an expert by any means on data visualization in Julia. It's still something I'm picking up and learning, but it seems to be. I'll say my general takeaway so far is that it's easier than in R, but the graphics don't seem to be as nice. But if I can't answer any questions, I'd be happy to. And I think, oh, there's one more thing I wanted to show you actually. If we go, let's see, back here, if you're on the command line, there is another thing we can use. So we'll be using plots again. It'll load it in this session. I just think this is kind of nifty. If we do specify Unicode plots, hey, this will allow us to graph out inside of the terminal, which is nice for kind of doing quick explorations of data. Hopefully this finishes quickly. All right. Um, all right, and then so if we just real quick, we'll do like a random. All right, so that's pretty cool functionality. I don't know, very kind of 90s aesthetic. Uh, so it's I don't yeah. If there are any questions over data visualization or anything in Julia, that's all I've got. So thank you all for participating uh, and taking the time to be interactive and everything. I really appreciate it.